Mass is the fundamental measure of the amount of matter contained within an object. It is an intrinsic property, so it does not change with location. Whether on Earth, the Moon, or Mars, an object's mass remains the same. Weight is the gravitational force acting on an object's mass. It depends on the strength of gravity, so it changes from one planet to another. Simply remember, mass is the amount of matter, while weight is the force of gravity acting on that matter.
Let's understand the fundamental differences between mass and weight. Definition: mass is the amount of matter in an object. Weight is the gravitational force acting on that object's mass. Core nature: mass is an inertial property, meaning it resists changes in motion. Weight is a gravitational force caused by gravity. Dependence: mass is independent of location. Weight depends on the local gravitational field, so it changes from place to place. Value stability: mass remains constant everywhere in the universe. Weight changes with location, altitude, or planet because gravity is different. Zero condition: an existing object always has mass, so mass can never be zero. However, weight can become zero in deep space, where gravity is nearly absent.
Now, let's compare the measurement and physical properties of mass and weight. SI unit. Mass is measured in kilograms, or kg. Weight is measured in newtons, or N. Other units. Mass can also be measured in grams, pounds mass, and slugs. Weight can also be measured in pound force and dynes. Quantity type. Mass is a scalar quantity, so it has magnitude only. Weight is a vector quantity, so it has both magnitude and a downward direction. Measurement tool. Mass is measured using a beam balance or an inertial balance. Weight is measured using a spring balance or a platform scale. Formula. Mass can be calculated using mass equals force divided by acceleration, or m equals F/a. Weight is calculated using weight equals mass multiplied by gravitational acceleration, or W equals mg. Let's see how the weight of a 100-kilogram object changes on different celestial bodies. Notice that the mass remains constant at 100 kilograms everywhere because mass does not depend on gravity. However, weight changes because each celestial body has a different gravitational pull. On the Moon, with a gravity of 1.62 meters per second squared, the object weighs only 162 newtons. On Mars, its weight increases to 371 newtons. On Venus, it becomes 887 newtons. On Earth, where gravity is 9.81 meters per second squared, the weight is 981 newtons. On Saturn, the weight is slightly higher at 1,044 newtons. Finally, on Jupiter, which has the strongest gravity among these celestial bodies, the object weighs 2,479 newtons.